Hello, and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about PL Rust, its 1.0 release, and how it implements trusted language support in Postgres. PL Rust, for those of you who are not familiar, is a way to use Rust to create your user-defined functions in Postgres. Similarly to how you could use PL pgSQL or PL v8 to run custom code in Postgres as part of your application, you can now also do this with Rust code. Early this week, version 1.0 was released by the PL Rust team. I think this was a tremendous amount of effort. The team behind PL Rust has previously created pgx, which lets you create shared library type extensions in Postgres. PL Rust, on the other hand, is for creating user-defined functions that lets you extend your application logic on the database side by using Rust. PL Rust has a few trade-offs to think about. A lot of them come from the fact that you are using Rust. Rust has to be compiled. That compilation can be slow sometimes. The very first time you're creating a function will be slow, but then when you're executing it, it's going to be a lot faster. Here, for example, they claim this is 10 times faster than PL pgSQL. If you have really complex database-side logic, this might give you a huge performance benefit. Obviously, you get other benefits from Rust, such as the fact that you have type definitions, you can analyze all your code at compile time, you will have better error handling, things like that. When they released it, there was actually quite a good discussion earlier on Reddit where they talked about some of the trade-offs. And one of the challenges right now is that it's a bit challenging to get running. It's not just the Postgres extension that provides PL Rust that you need to install, but it actually uses a custom Rust standard library behind the scenes, as well as a custom Rust compiler driver. Now, this is early, but Yurii from the Postgres project started testing out PL Rust. This was a very long way for Yurii, but one of the things he learned here is that PL Rust does take quite some space to compile initially. It does take about 8 gigabytes just to get all the dependencies in place. And then you also need to have a good amount of RAM, roughly 16 gigabytes of RAM to build PL Rust initially. This might make it a bit frustrating if you're including it in your build environment. Also, first-time function compilation, as mentioned earlier, does take quite a long time. But I'm sure that the team behind PL Rust will spend time optimizing these things. And so I think we'll see a lot more improvements over the next months and years. Now, one thing that I found interesting is the claim that it is a trusted language. If you're not familiar with the definition of trusted, trusted means that you give permission to any user in the database to create a user-defined function with that language. Somebody could just go in and create a PL Rust function. As Postgres documentation notes here, the trusted flag should only be given to languages that do not allow access to the database server internals or the file system. And that last part is really important because the big risk here is that you have a Postgres user, like just a regular application user, escalate their privileges through means of a user-defined function. In a standard Postgres install, PL pgSQL, amongst a few other things, are considered trusted. And then untrusted would, for example, be PL Python, which is why you see, for example, Amazon RDS not supporting PL Python, but they are supporting PL pgSQL. PL Rust considers itself trusted. And in order to do that, they've actually disabled quite a few features to preserve that security. You can't use unsafe in your Rust code. You have restrictions on which crates to use. And in addition to that, they're also restricting a few other things. If you have specific Rust crates you want to use, you actually have to explicitly allow those. You're guaranteeing that PL Rust can consider those safe. You actually do have to vet these crates and make sure that they don't let you escape into the operating system level. And then what they've done with the standard library in Rust, which I think is really impressive, is they've actually gone and they've essentially reworked the Rust standard library, which is a version of the Rust standard library that lets you write standard Rust code, but in behind the scenes, it either calls into Postgres functions or errors out. And through that, lets you make sure that the Rust code that uses the standard library doesn't escape to the operating system level. All in all, you can see that there was a lot of work put into PL Rust, and congratulations to the team to releasing the 1.0 version today. And I look forward to seeing more of PL Rust in the future. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.